Welcome to the channel, guys. Today we are gonna learn mutability in Rust. Mutability is one of the main concept of Rust, and it is one of the unique features in Rust. So let's just start with the creating a file. So let's start. So let me create a file named mutability dot yes mutability.rs. Okay. So let's create a function main, and then we'll do what is. So what is this mutability concept? So uh, the main concept of this mutability means, what is the usage of this, what is the purpose of this. So firstly, when you have program, when you have a large program, then it might happen that there are many unexpected changes that you don't know about. Means if the variable data is going from the from many sources, it is interacting with many functions, with many structures. So it might happen that you might not know what how the data is being changed, and you are not clarified, you are not clearly knowing about how the data is changing. So instead, so when you have this mutability concept, so you know that I have, because you are a programmer, you have coded that. So you know where I have done the where I have uh, set a variable mutable. So when you see a variable, let's say when you see that lex is equals to 8, let's say, so you now know that this 8, this x is holding 8, and by default rest variables are what? Immutable. So this is a immutable variable, that this x, then you are very much known, you are 100% sure that this is not going to change anywhere. So okay. So this is like the main purpose of the rust, means this mutability in rust. Another main purpose is concurrency guarantees. Like there is a concept in this rust, that is the references. We'll do it in another video. But what happens is, like, you are um, reference is what, like when you create a variable like this x, now this variable 8 is getting stored in a memory location, and that memory location ownership is given to this x. Now whenever you want this x to be used by someone, let's say y is equals to x, now what happens is this x ownership is given to this y, and if you try to print this x, this y, let's say this x equals this, y equals this, those x comma y, here you will not get error, because let's run it and then I will tell you what it is going to do. Option underscore result, and then cargo run hyphen bin mutability. Okay, so let's run it. It's being run. So x equals 8 and y equals it. But if you have like these kind of things, mm, I love rust. Okay, and now you, if you try to print this, what will what will happen, you can see. Okay, yes, yes. Did I saved it? Not. Mm, here you should get an error, I think. Let y equals x. So there should be an error here, because what I have learned is that, let me tell you that the this is not, let's say I'm creating a string. This the characters inside the inside this double quotes, in the inside double quotes is actually called as string literal. So maybe that's why it is not giving the error. Let me save it and now run it. Yes, now you can see what the error we are getting. This is a string, I love rust. Now you have sent it its ownership to a y, its ownership to y. Now if you print the x and y is valid because y has the ownership of the I love rest string. But x, here you actually pass the ownership, so now x is not valid. If you print like this x, we try to print x, if we try to print here x, you will still get error. What error we are getting? We are getting that is move occurs because x is type string which does not implement the copy trait. Now this is a and now value moved here. Okay, value, we moved the x value to y, and now we are printing, so it is giving error. But if you try to print y, you won't get any error. Yes, so you got. So this is the concept of this when you have like this, let n is equals to 8 and let m is equals to n. Okay, and then when you try to print m comma n is equals to, let's say, now you're printing, okay, sorry, so m comma n, and now if we try to print that, you will get, you will don't get any error because 8 is what, it's a primitive type integers. You are, when you are doing this, it is just copying the n value to m, not assigning the ownership here, because the primitive data types are just copied and then given here. Like there is a memory location for n, and when we create it for n, another memory location is created, and then n's value is copied to m. So this is what the reference in the integer primitive types. But when you have a string, when you have a string and you try to use that to take the ownership, the full ownership is given. So what is the uh, remedy for this? So you can do what you can do this is this, that you're passing the reference. Now if you print, now we print x equals this and y equals this, and if we, when we print this and we run it, we are not getting any error, because now x, there is only one location, there is only one memory location, and we are pointing to the location with two pointers, that is x name and this y wave. These two variables we are using to using to point to the same memory location, and that memory location is holding I love rust. So this is how the concept of references. Now when you try to mutate, by default I set that variables declared, let's say we by default the variables, by default the variables are immutable. Here it is immutable. What does immutable means? You cannot modify it. So let's say I try to modify it like n plus equals 1. Okay, n plus equals n, that is n is equals to n plus 1. And now if I try to print n, let's say now if I try to print n and just run, you will get that first assignment to n, yes, फिर cannot assign twice to immutable variable. This is a immutable variable, it is immutable, and you are assigning a new new something. It is like this, it expands like this, n equals n plus 1. So this you are assigning n the n plus 1 value, so it is getting assigned twice. Now you will get an error because it is a immutable variable. So for this, for mutating it, for changing it, we explicitly need to write this mute keyword. Now if you do now if you run, you will get the error, you will not get the error. So this is how. So you can see that when you are when you have the control which particular value should be mutable, which should be immutable, then you have the full control of this. Now the now the second thing is that here in other programming languages like Java, C++, you have a concept of garbage collector. What does garbage collector do? Garbage collector is just used for used for vanishing the unreferenced or unused data, unused data, when you have like when you have a object and you have just used that, and not, the program does not need it later. So what happens is, the garbage collector comes into the picture and it just vanishes. It just dereference the data, and now you have the space, memory space again allocated, and that can be used to allocate another variables in the next versions of the program, like next in the next lines of the programs where you need that space. But this Rust completely overrides this concept of garbage collector when sorry, when you have this concept of immutability references, mutable references. So what can you do? You can have uh, you have the control. So whenever you see that this variable is no longer needed, then you can just use that memory location to assign a new variable, and just you can do anything. So this is how this Rust concept, this mutability concept in Rust enhances the performance of the program. Now, the most important thing is that clarity. You are very much aware about how the program, how a variable, how a particular structure is gonna behave, how a particular function is gonna behave, because you know that which is means this variable is mutable or not mutable. So you know it can never be changed. If a variable is mutable, you have you are fully aware that yes, these are the places where it is getting mutated, and later it is not mutated because you have that implementation, right? Maybe if you want to mutate it later, you can do that. So this is how you are very much aware of the program, and even you are aware of the memory efficiency, and this this concept enhances the memory indirectly, we can say. So this is how the mutability concept is very important in Rust. Now let's start with some examples. As we know, these by default the variables are immutable. If I try to give it a new value and println, let's say the m value, and if you try to run it, it will give it error. That is, you need to tell it to mutate for using the mute keyword. Okay, now it's getting. Now we can have the, like, when you have the mute keyword, you can actually do this mutability. Now there is one thing for references as we talk about. So let's say you have this mutable value m, and now we create two references of it. Let m1 is equals to reference, that this m person means reference, we are referencing that. Let m2 is equals to, again take the reference of the and now if we print this m1 comma m2, m1 comma m2, and even you can print this actual m, you will get the you will not get the error. Okay, I'm getting an error. Local variable with a similar name m exists. Okay, m3, not m3, it's m actually. Okay, just run it, and we got 8888. Okay, this is called as the taking the reference of it. Okay, now if we take the mutable reference, let's say we are taking a mutable reference. Okay, mutable reference of it, and now trying to print this m3. Let's say we are printing m3. What the error you are going to get, let me tell you that. Okay, so this is the concept of like this m1 m2, these are like readers. They are not, we are have we sent a mutable reference. So mutable, if you have to give a value like m1, so the control that it can change the value of original m, so you will pass like this mutable, so it can mutate the m variable, m value. Okay, so because we have not given this, these people are what, readers, but this m3 can what, can do something like this. Let's say 7, we added with 7. Now m3 directly changes the value of original m, and if you print that m, you will get you will get plus 7 added there. Okay, so these are readers and this is the writer. Okay, so there is a read write conflict here, because one might write something and people are reading. It may happen that he writes, he hasn't written yet, and people are seeing, these people has seen the value 8, and these people say, this person can see the value 8 plus 7. So it might create some inconsistency in the data, because maybe you are going to use this m1 variable into a large calculation, m2 variable in the large for the large calculation. Now if you want the data to be consistent, to behave the program to behave as consistent as possible, you need to resolve this read write conflict. These people are reading and this is writing, this is writing. So there is a concept in this mutability of Rust, that that there can be multiple multiple references that are immutable, or there can be only one mutable reference at a time. So this is what it is. So you can have multiple references. If I don't create this, let's say if I don't create this, I can have multiple variable multiple things like this. Just create this, nothing, 4 from 5, and if I just run this, you're not going to get any error. Did you get for 5 4 5 5 3? No, you didn't get. But if you do this, if you run this, now you are going to get error, because what, okay, it is a reference, so you have to do this with, so this asterisk is what, dereferencing, that is you are actually this is a reference, so you are like pointing, but if you have to change the value, you have to use this asterisk sign, so to actually change the variable. This is similar to the pointers in C. Now you are getting this same error, that is immutable borrow occurs, mutable borrow occurs. So immutable borrow later used here. So it is like this, that no, at the same time there can be only one mutable reference, or there can be many immutable references, or there can be only one mutable reference. Now let's check this. If I do this and let's see what happens, you might not get error. Why? This is the concept. Now see, m1 m2 are here. After this we created m3. Can you see later are we using m1 m2 later? No. So that means this is the end of the scope of the m1 m2. So here now you know that there is the end. So this line is the end of this line. Yes, this line is the end of the m1 m2. Later we are not using here. Still the program is running, but are we using m1 m2? Is there m1 here? Later in the program, is there m2 here? If we do this like this, if we do print ln, and if we do like this, that m2, okay, m2, okay, m2. Now if you run, you will get error. But so that means if m2 is here, that means m2 m1 has died here, but m2 is still living till here. After this m2's scope is ending, right? So when the m1 m2 both are dying here, both don't they are except their scope has died here, then we can say that we can use m3, because later no m1 no m2 is gonna read. So there is the so this read write conflict has been resolved. Or else you can do something like this. or else you can do something like this. There is also a concept. Let's say you are using M2, so you must make this like this. And now if you do, and if I run this, oh, there's an error. There is an error. Entry. Did I save it? Improving borrow. M3 println M3. Now you should not get an error as I have learned it. So M3 plus equals, so there's a, so this is the scope. Now its scope starts here and it is ending here. Maybe it's like this. Okay. Yes. So what is happening? You just created mutable reference here. Its scope starts here. It scopes end here. Now you can create multiple references. So this is how we are using this mutability concept in Rust. Okay. Then there is a concept of shadowing. Okay. There is a concept of what we call as shadowing. So let's say we have let x is equals to 9 to 12, and we can have the same variable. When we create the same variable with 45, now what you are saying is that x, let's x hold 12. Now x is holding 45. You just created the same variable with same name. Now what happens is it overwrites, it takes the name of the x again, and it is having a new value 45. So this is called as shadowing. You are not referencing, you are not taking the ownership of for that x, previous x. You are actually overwriting the, you are taking the ownership. You can see that you are using the same variable but with a new memory location, right? So this is how you can, this is called as shadowing, the very basic which to do somewhere. Okay. There are other languages which oppose this, like declaration of the same variable, where you, when you redeclare, you are actually overwriting the previous. Now if you run, if you print this x, you will only get 15 value, not, means 45 value, not 12. Okay. Now there is a mutability in struct also. If we create, if we can create a structure like this, struct my, okay, and it has let's say it had let x equals colon I32. Okay. So we have x, so we don't need to use x here, and this is how, and y maybe, let's say I32 again. Okay. And now we create the object of it. Let object obj is equals to my, and you are having x as for 34 and y as 45. Okay. And now if you try to use, if you try to do that like this, x is equals to 56, now you will get an error. That is mute, it is not mutable. So if you will use it as mutable, and now if you change it, due to one previous error, unused, what is it, what the error is? Yes. So okay, I got an error because I need to, because it's a statement, right? So we need to use this semicolon, and now you're getting 45. Means the, if you print this, println and obj dot x, you will get that 56. Okay. So this is how the mutability happens in this rest. So thanks for watching the video. Thank you.